Hello everyone and welcome to our next video on Simple AI with Python and Colab. What we discuss today is detecting a voice command, how to find a matching word in a speech flow. And you know that in today's speech recognition devices there are neural networks used, and the role MFCC coefficients play in command detection is huge. But still, what if we try to find a matching word by direct audio wave comparison? That's what we discuss today. First of all, let us import some necessary libraries. We shall use Librosa and IPython display to work with audios, and TTW dynamic time warping to compare numeric vectors, and PyPlot to plot our audio waves. Next, let's look at the nature of audio waves themselves. You see, this is a part of audio wave. For your eyes, this jagged line means almost nothing, but your ears will interpret this as "This Boy" by the Beatles, so that all the instruments, all the voices, all the real lyrics, everything is genially coded in a single line. That's the magic, surprising nature of audio waves. And the key idea is that if everything is coded by the wavelets, by specific waveforms, we can try and match the lines, these jagged lines. If they are similar, it means there is the same word, there is the same loudness, same tone, and same word, same letters are used. So we have two audio files. One is a phrase. Let's play back this.
There is a flower in the picture.
There is a flower in the picture, and we have a word. Let's listen to it first.
A flower.
A flower. The word and the phrase have been recorded separately, so that the word has a varying background noise and different tone of pronunciation and different loudness. Still, we hope that its wavelets, their waveforms, their specific patterns are the same as patterns of this word in the phrase. Let's look for the command. What we do is we do the loop through the length of the phrase, and each time we take a pattern, shifting it step by step throughout the phrase, and we compare our separately recorded word to the same length of wave in the phrase, and calculate the matching metrics. It can be mean squared error, or you can use mean absolute error, whatever. I use dynamic time warping FastDTV. And finally, we will sort the resulting list ascending order, because the less is DTW, the better is the match, so that best matches come first. Let's run. It takes some time, so we do the cutout, which is equal to our word length, and we append our metrics calculated here. And finally, the best match which comes first. Let's carve it out of the phrase and listen to it.
The flower.
You see, the flower. So it has found a correct matching word. And let's represent it visually. So how can we see it with our eyes? I cut out a fragment from the word and cut out the fragment from the match. And you see, there are similar patterns. It is some letter, maybe flower, I don't know, but it is definitely similar pattern. There are some jagged ranges alternating throughout the fragment. Okay, so we solved our task. Thanks for watching. Subscribe to the channel and subscribe to simpleai.net. See you, bye.